Chapter 2, Function Circuit Components. But now you're somewhat familiar with the various components of the Ametuer radio. The chapter is going to learn with the function some of the most important components of the radio circuit. So far we learned of the very simple exemption of a hurdle or two. The chapter is a little bit more complicated, but it does not let it scare you, but it really is not that. Some of the topics will cover the quartz, crystal, chokes, power supply filters, regulation, bleeder, resistor, diodes, some other troubleshooting hints. The appearance of the components help us. You locate trouble such as blue haze and electron tube, the red hot plate and electron rectifier tube was discussed in this chapter. Obviously, are limited to the amount of space that we can teach with all there. There is no every possible component you'll never ever encounter. You may ever there is enough here that they can go get you past the novice FCC exam on the flying colors. Study each answer for the if you give it, will not only pass the test, you will have some understanding of the amateur radio electronics. Now let's go with the questions. 2-1. What is the function of the quartz crystal on a radio? When placed with electronics, the crystal acts like an H merit series resistance circuit with electrical circuits associated with the crystals can be represented on an equivalent circuit. Show the 2-1 quartz crystal equivalent circuit composed of the resistance, inductance, and capacity and metal plates. Capacitor 1 crystal holder. The crystal is now with a vibrating circuit is acting only as a capacity series combination of the inductance, capacity, and resistor represented with the electronic equivalent of the vibrating characteristics, crystal characteristics such as since the core crystal is equivalent to the resonance circuit, it's used to place usually tuned circuits in the oscillator section of the transmitter of the high merit over the crystal provides stability that cannot be matched ordinary by inductor capacity components. 2-2. What is the purpose of the ARF choke? The ARF choke is placed to prevent passage of radio frequency energy. Choke offers a high impedance of the radio frequency but passes DC. What is the principal function of a filter over the power supply? Well, the principal function of a filter power supply is to produce the DC voltage sufficient smoothly to avoid undesirable coupling of the AC components in the electrical circuit with the pursuit of the DC voltage presented with the output rectifier system, where directly applied to the vacuum tube pulsation would cause improper operation of the tube. 2-4. What is the effect of the filter choke? Large value of DC flow. During the period of the rectifier conducting choke, with opposed to the current buildup, with the rectifier is not conducting the input return towards zero, the storage energy of the choke supply of the current load of the longest current exceeds the minimum value, depending on inductancy of the choke and with the regulation output voltage of the remaining fairly high with low current loads. Ordinary filter choke functions in much the same manner as electrolytic filter capacitor. 2-5. What are the characteristics of the capacitor filter and a power supply opposed to a choke input filter? Capacitor input filter capable of supplying a higher DC voltage with given an input potential with the under fairly light load. Since the input capacitor charged with the almost peak input voltage, a properly designed capacitor for the input filter will provide a high output voltage comparison to a choke input filter. Capacitor input filters typically use an application where the current drain is very small. As shown in figure 2.2, when a pair of vacuum tube rectifiers use the two full wave rectification, output voltage E with remains at almost a constant average level over the load resistance is not too low. Plate current is of the ampere B rectifier increases resistor 1. Decreases peak plate current draw and be lower than the peak current rating of the rectifier. Capacitor input is characterized by poor regulation with the full load voltage. Load resistance very low. It drops significant figure 2.3 in comparison with the choke input with the filter capacity with the input type exhibited great change in output voltage, no load, full load condition. So here show the amperes and the average peaks. Shows voltage 1, voltage 2, inductance coil, resistor inductance, and capacitor, and earth ground. Same thing, if a capacitor input filter effective output voltage, you see the average, effective capacitor input with very low resistance. Compared to the capacity of the input filter with the choke input filter will have the following characteristics: low output voltage, full wave circuit with a direct input current. Output cannot be exceed with the average value with the input. High current output with a due with a lower peak with a current with a higher average current over the rectifier as illustrated in waveform 2.4. Better regulation, less change with no load with the full load conditions. Figure 2.5 show the effect of a load on the terminal voltage, both kind of filters. 2.7. What is the definition of the voltage regulation as applied with the power supply supply voltage regulation variation refer to DC voltage under changing loads conditions. Negligible voltage change of B positive line during a high low current range referred to as good regulation. Power supply whose output drops significantly when the load is applied is said to have poor regulation. For this reason, the term percentage of regulation is actually a misnomer. It refers now to the percentage of regulation of the percentage of error in regulation. Actually, the increase expressed in percentage of regulation as a high figure as such as 98.99 would be desirable. 2.8. What is the principal function of swing choke in a filter system? Swing choke has reduced air gap and decreases reluctancy, offers better power supply regulation. Ordinary choke sense inductancy increase with light loads, decrease with heavy loads, and the output most uniformly regulated over the broad range of changing load conditions. So 2.4 shows the choke input with showing higher current output. 2.5 show the capacitor choke load effects, filter output voltage, choke input filter, capacitor input filter, rectifier peak output voltage. What is the purpose of the bleeder resistor used in the connection with the power supply? Bleeder resistor bleeds off the DC voltage from the electrolytic capacitor of the power in the power supply when the power supply is turned off. Also, the bleeder resistor will use the choke input filter provide consistent minimum load on the filter, thus improving regulation. 2.10. What is the blue haze space between the filament and place of the high vacuum rectifier tube indicate? Blue haze between elements with any of the tube older than the gas-filled tubes, which does not include the high vacuum rectifier, indicate for the presence of gas. One of the requirements for the high vacuum tube is that it must remain practically free of the internal gas during operation. Precaution is taken during the manufacturing of the pump. The air from the tube is not fully evacuated because of the defect of the manufacturer deterioration during use. Flow of the current such of the tube is erratic and quite unpredictable. The tube must be replaced. If the high volume rectifier high voltage power supply should suddenly show severe internal spark and fail to operate, the elements rectifier should be checked with the possible failure to be before installing the new rectifier tube. Sparking in a high vacuum rectifier simply with excessive current or the other indicative is often indicated as short circuit. Before replacing the tube, the filter capacitor should be checked. Show the B positive supply line feeding battery. The B positive supply line load use of the bleeder resistor chain with the value drawn with excessive current, but this is rare. First step, it should be to remove the load from the B bleeder resistor line to the ground with rectifier tubes on the circuit. The dead short should still be low indicated. The problem is most likely shorted electrolytic, which means often caused by applying voltage in excess. Electrolytic capacitors rated maximum working voltage. 2.12. If the plate or plates of the rectifier tube suddenly become red hot, what might be the cause? Red hot plate indicates excessive current. Most frequent cause excessive plate of current of low resistance between bleeder positives and the ground. The short is anywhere between the cathode rectifier's output terminal disconnected by bleeder positive supply. Alright, 2.6 show the diode pictorials. We have a single diode, rectifiers, Zener diode, and reference diodes. In the condition after the B plus line with a disconnect with the cathode condition with a probable attributed with a short rectifier filament with a high voltage transition former. Alright, discuss application of electronic characteristic rectifier single Zener diodes. Pictorial representation various diodes shown in figure 2.6 with a very limited representation wide assortment and in the case design. However, the shape of the characteristic curve of the diodes with very similar primary current and voltage limited relation for the different. 2.7 show the typical curve of the junction diode. Show the two different kinds of bias. The bias of the positive negative junction is the difference between the anode and anode of positive material and the cathode negative material of the forward bias for the application of the voltage of the cathode to anode material or positive negative and positive material. The positive anode material is positive with respect to the cathode material is negative. Positive anode material becomes negative with respect to the anode cathode material, the junction is reverse bias. So we have forward current, forward bias, reverse current, and breakdown point. Application graded with the greater amounts of forward bias called for the more forward current with the until the power handling capability with the diode achieved in less limited external circuitry. Small amount of the forward bias cause very little current flow with the internal barrier potential overcome potential difference vary of the diode to diode, but usually no more than a few tenths of a volt. The reverse bias produces a very small amount of reverse current until the breakdown point is reached. There is an increase of reverse volt bias, which is large increase of reverse current. Therefore, breakdown and see the ratio of the forward with the current reverse is large. For example, the milliamps or microamperes over the amperes and milliamperes. The change of the temperature may cause alteration in characteristic curves, slope of the curve, the ending point, breakdown point, and amount of reverse current. Rectifier diodes. Rectifier diodes are used primarily with the power source. The diodes are primarily silicone type because of the material's inherently reliable, highly overall performance compared to other materials. Silicone always allows higher forward conductancy, lower reverse leakage current, operating at a higher temperature compared to the other materials. The major electronic characteristics of rectifier diodes are listed below. The DC blocking voltage, minimum reverse DC voltage will not cause breakdown. Average forward voltage drop, or VF, average forward voltage drop across the rectifier given the specified forward current temperature and usually specified rectified for a current of 60 hertz. Average rectifier forward current is average rectified current forward current is specified temperature usually 60 hertz resistive load. Temperature is normally specified with a range of typically negative 65 to 175 degrees centigrade. Average reverse current is specified temperature usually a 60 hertz. Peak surge current or ampere surge, peak current surge specified given the number of cycles, portion cycle, for example, the 1/2 cycle of 60 hertz. Single diodes varies with the categories of the general purpose high speed with a paramedic amplifier. These devices are used with mixers, detector switches, as well as many other applications. Single diode major electronic characteristic peak reverse current, maximum reverse voltage. It can be applied by reaching breakdown point. Reverse current, small value of the direct current will flow with the semiconductor to the reverse has reverse bias. Maximum forward voltage drop, inductancy, inducted forward current, voltage force at amperes force. Maximum forward voltage drop diode indicating with the forward current. Reverse recovery time. Time required for the reverse current to decrease value equal to forward current value of the amperes reversed. The step-up function of the voltage is applied. 2H of the rectifier single schematic representation forward current, cathode N type negative, anode positive type. Zero dioide schematic representation BJ and Zanier. Rectifier single diode shown figure forward current 2.8 forward current flows with a point of arrow reverse current in the arrow. Zanier diodes uniquely compared with the diode of the design operate reverse bias the average avalanche breakdown region of the device with the regulated clippers coupling device other function major electrical character zeros diodes nominal zero breakdown sometimes zero max zero and sometimes zero max zero minimum used to set absolute limits between when the breakdown will occur. The maximum power dissipation of the device capable of handling since the voltage is constant here is the corresponding current maximum. Schematic diagram 0 shown figure 2.9 zero current flows the direction arrow of the main schematics of the distinction not made with the diode single diode symbols used. Chapter 3 Practical Electronic Circuits.